Hey everyone, welcome back to the channel. I hope you all are doing well. Uh, let's see today's daily challenge on Leetcode. Okay, so we have, I guess, a pretty simple problem for today's challenge. Count the submatrices with top left element and sum less than k. So you are given a zero indexed integer matrix grid and an integer k. Return the number of submatrices that contain the top left element of the grid, okay, and have a sum less than or equal to k. So you are allowed to choose only the top left portion of the matrices. Okay. So if you have a matrix which is like this, you can only choose the submatrix which is like this or like this or like this. So I hope you do understand what they mean. You have to include this top left element always in your current submatrix. Okay. So that is what, and you need to have that submatrix. Okay, you need to count the number of submatrices that contain the top left element of the grid and has a sum less than or equals to k. Okay, so that's what the problem statement says. And if you try to see this, they are doing this, and they got four such submatrices whose sum is less than equal to k equal to 18. Okay, so if you see this submatrix 7 7 6 and plus 7 6 3, it is 16. 7 6, it is 13, 7 and 7 6 again. So four kind of submatrices they got. So yeah, how to solve this problem? You can definitely look for the prefix approach. Okay, so if you let's try to write this matrix and try to visualize 7 6 3 6 6 1. Okay, 7 6 3 6. 7 6 3 6 6 1. Okay, now I definitely want this matrix to edit and write the prefix matrix in the sense that each I comma j cell. So I want that if I have a matrix like this, my I comma j cell should contain the sum that this whole matrix has. Okay, so yeah, I hope you are clear about the approach, that uh, my I comma j, I will try to fill my I comma j cell with the sum of all the elements in this particular matrix. Okay, so that is what I will try to do. So if I tell you that if this is my I comma j cell, then only this element will come. Okay, then again, if this is my I comma j cell, then I will try to have the sum equal to these two, this matrix. Okay, so it will be, let's say if this was y, it will be x plus y. If this had initially y, okay. Then again, if you call for this, it will be x plus y plus z. Okay. So I hope you do realize what will the base cases and stuff like that do. So what I want to convert it into. So I basically want it to have something like this, and see, is 32 minus 7, it will be 25, I guess. 13 plus 6, 19 plus 6, 25. Okay, and if you look for that, 6 plus 6, 12, 13, 14, 15 and 16. Okay, so that is what. So now this cell should contain all the elements, sum of all the elements. Okay, so not only 16, it should be something like 6 plus 6 12, and 4 16 plus 6 22 plus 7 29. Okay, so I want to store a matrix like this. So how will I calculate the ith cell? Okay, so for the first row it is very simple. This is 7, so for the first row I will just check my previous row, previous cell element and add that. Okay, so for this element I just check 7 plus 6, it is 13, and this, for this I just check, it's 13 plus 3, it's 16. For this again it is 13. For what we will do for this, if you see, if I try to just add these two, 13 plus 13, it will be 26. Okay, but actually answer is 25. So what is going on? What exactly is going on? So if you notice something like this, this cell contains the sum of, let's say this was x, this was y, this was y, this was z, okay, and this is p. So what should be my result? My result should be x plus y plus z plus p. But if you try to have this, okay, now y, what is the element which you calculated here? Here you calculated to be x plus y. Here you calculated to be x plus z. Okay, and this p. Okay, okay. So if you try to sum these elements, what you will get? X plus y plus x plus z plus p. So you got 2x plus y plus z plus p. So what did you notice? The difference between these two? X is counted to be twice. Okay, so you need to subtract this element. Okay, so the intuition is also mathematically also you saw, but intuition wise, if you try to see, it is also very simple. That if you try to fill this cell, okay, if you want to use this and this particular cell, so what does this cell contain? It contains the sum of all elements of this matrix. Okay, and if you talk of this cell, it contains the sum of all elements of this particular matrix. So if you take the sum of this as well as the sum of this is the overlapping region, right? This is the overlapping region which you are counting twice. So you need to subtract it once. Okay, that is what also you get over here. Uh, you get this area and this area, and in the process you overlap this x twice. You overlap this x twice. Then what you want actually? Then you do the current cell also, sum the current cell also, and then also subtract this. So if this is I plus I comma j, okay, so let's write it properly. If this is I comma j, this is what, I minus 1 j, this is I j minus 1, right? So you need to subtract this I minus 1 j minus 1. Okay, so what will your formula look like if you want to calculate the prefix sum? So for prefix sum of a 2D grid, the formula is something like this only. uh, Grid ij, you add the current cell. Okay, you add grid I minus 1 j, you add grid I j minus 1, and then you subtract grid I minus 1 j minus 1, because that was the overlapping region which you are having. Okay, again, like this I minus 1 j minus 1 grid will have uh, the sum of this whole grid only, so which is nothing but the overlapping region, and we subtract that. We subtract that because I want this whole region to be counted once. This whole region to be counted once. I hope you can visualize it clearly. This is one matrix. This is one matrix. You subtract this one and add this cell also to get. Okay. So yeah, I hope you can do that easily. So for at first, your base cases will be something like you compute the first row as well as the first column in a separate for loops, and then you go for each individual cells. So yeah, you can do that easily, I hope. If you have understood the solution, you are actually free to drop out from the video also if you are confident that you can solve it on your own, because in this way only you can improve. So yeah, so let's see. We have this m and n for I equal to 1, I less than m, I plus plus. Uh, what is it that you want to store? Grid of I0 should be equal to grid of I minus 1 0. Okay, so the current element plus the last element. Okay, uh, you can copy this whole for loop uh, with j. Okay, so you replace I by j. You could have kept it I also, but yeah, just for the convention, and you write this j minus 1. Okay, so you are having this ready. And in this process, you also got the ith row all the elements in the first row and the first column. So you can just check whether they exceed any sum or not. Okay, this k value they exceed or not. So you are never iterating through the first cell because that is as it is. So you can just have something like this: if grid of 0 0 less than equals to k, count plus plus. You take care of the first cell over here. Okay, and also here you want to take care of all the elements in the first column, and then again here you want to take care of all the elements in the first row. Okay, here column number is varying, column index is varying, so it means it is the first row. So you take care of all those indices, and then a final for loop which I will have I less than m I plus plus for int j equals to 1, j less than a, j plus plus. And yeah, so now you can easily calculate the grid ij. What was my formula? Grid ij plus equals to this element, and this element. Okay, plus equals to includes this already. So grid I minus 1j plus grid ij minus 1 minus grid I minus 1 j minus 1. Okay, I hope that was simple only, not much difficult to think. And you can have this whole thing again. If grid ij at any point, if it is less than k, you just want to increment this count because this is the count which you want to return. So you want to count the number of submatrices which has a sum less than k. Yeah, so you store the sum and just count and return it. I hope you guys, even if you directly submit this for all the cases, it should work just fine. So yeah, okay, so we are getting a wrong answer. So we must have done some mistake. Let's try to check what was our fault in this. So we have this grid integer k. If the first element is less than equals to k, we just increment the count. Okay, so you see this is both m and n. Okay, it's both m and m, so you want to have that changed. Let's see. Yeah, it did work for the two cases here. Let's try to submit it for all the cases and see. Yeah, it does work, and we have a pretty decent runtime as well as memory complexity. Yeah, that was all. That was all for this problem. I hope it was simple enough and easily understandable, and you have no doubt in this. So yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.